Hello and welcome to another power session with Mama L. We're going to be talking about perimeter and area today. After this session, you will know what perimeter and area are and how to calculate perimeter and area of some basic shapes. So just to start off with, peri means around. Imagine Perry the platypus walking around a pool. It's a little corny, yes, but it's definitely memorable. So every time you're like, wait a second, what's that word perimeter mean again? Just picture Perry the platypus walking around a pool. And it's good to know, don't just memorize the rules of these formulas because there are formulas all over the place when we're talking about geometry. But you need to understand where those formulas are coming from. If you understand and you have some of that background knowledge, that's really going to go a long way to help you. So let's start with that background knowledge here. Our world is not flat. We know that, of course. And we have these three dimensions that we tend to talk about. First dimension, second dimension, third dimension. One-dimensional is when you have straight lines, and that's when we talk about perimeter. We're looking at how Perry the platypus might walk around a pool, right? We're going to add up the length of that distance as if we could take that distance and stretch it out straight and flat and measure that like a straight line. Two-dimensional is when you fill in a flat shape, like a pancake is a flat circle. So that space that fills in that whole circle is going to be two-dimensional. Now three-dimensional is when we suddenly give that flat shape some space or some depth. Okay, that depth is that third dimension that we're talking about. Most of the real-world objects you're used to dealing with are three-dimensional. So just to give you a quick idea, okay, remember again, straight lines, one-dimensional when we look at perimeter or the distance around any shape, even if it's a weird shape like a star. Two-dimensional is when we look at what fills a flat shape. So if I were to fill in this star, make it nice and blue, okay, all the space or the area inside that flat shape would give me that two-dimensional area. And then finally, if I took a flat shape and I gave it some depth, we can stretch that out and we'll suddenly give it 3 dimensions. Okay, not my most impressive drawing, but you can see that we can take any flat shape and stretch it out, and that'll give it some depth. All right. Another thing to think about are units. Units are what you're measuring with: inches, centimeters, feet, miles. Okay, and I'll ask my students, does 1 equal 1? And they'll say, yeah, Mrs. Landers, 1 equals 1. Well, then I'll say, well, does 1 cookie equal 1 airplane? And they're like, oh, yeah, wait a second, probably not, okay? So when you're talking about units, they matter. Because if I'm going to talk about something that's flat, I could say, well, I'm going to make a pancake. I'm going to eat 1 pancake today, and it's going to be, it's just going to be a tiny little pancake, 25 square miles. It's like, whoa, that's definitely not a very tiny little pancake, right? Miles matters, whether you're talking about that or centimeters, okay? And especially when you're talking about flat things, because flat things, they might be 1 unit, but that could be 1 millimeter, that could be 1 centimeter, that could be 1 mile. So you might see a pancake that's 1 mile thick and think, that's the biggest thing I've ever seen, right? Okay, and you might just think, like, surely that's not a flat thing. But if it's 1 unit all the way across, okay, 1 flat pancake, even if it's 1 mile deep, if we're measuring it in the unit of a mile, then that would be considered flat. So keep those units in mind. All right, so 2D shapes. You can tell I like talking about pancakes. We'll be talking about pancakes plenty, especially when we go into volume on my next session. All right, so rectangle. Now, when you look at the rectangle, you are very familiar with it. You've been looking at rectangles for a long time now, okay? And usually you hear that you need to multiply base times height or length times width to find the area of a rectangle. And maybe you know where that comes from or maybe not, okay? And I want to show you that on the next slide. But remember, perimeter, no matter what the shape, is just the distance around. So we could just add up a length plus a width, plus a length, plus a width, and that'll give us our perimeter. There are some shortcuts, so your formulas might look different. They might say, oh, just add your length and your width and multiply by 2. Or take 2 lengths plus 2 widths. Either way, you're adding up those 4 edges of that shape, okay? But again, back to area. I want to show you an example, okay? So if I have this shape, this is a rectangle, and if I outline it here on the grid, you can see if I said how many square units are we talking about? Well, square units is because when we're talking about 2 two-dimensional, that's a flat area, that's what's filling in our shape, we're going to have units squared. That's going to be our label. You don't have to square anything. It's no math involved. That's just how we acknowledge that we're talking about a 2D shape. Okay? And if you look, I have 4 squares in this row, 4 more, and 4 more. I have 3 rows of 4. So 4 times 3, or 3 times 4, is going to tell me how much area fills in that rectangle. So that's the basis. If you understand that, you're going to be really on a good track to understanding the rest of the formulas. Okay, we're filling in that space, and it's just by multiplying base times height or length times width, depending on what you want to call it. Okay, oh, and I should go back and say that would be 12 units squared. Then you have these shapes called parallelograms. Again, perimeter, you just add up the edges, okay? But for area, what do? Now that your base and your height look a little bit different. Well, if I were to go on and continue to draw a shape similar to the one that I made on the last slide, I'm going to make this shape now. Okay, so here's a parallelogram and it's tilted over, right? Well, the same thing is going to happen on this exact shape, this parallelogram. We're going to still do base and height, but a big red flag I want you to see is that I don't want you to multiply base times height. No, base times height, they have these perfect perpendicular relationship. It's got to be straight up and down, making kind of like a T shape, right? So your height is not that slanted edge, and that's what a lot of students do. It's going to be the distance going straight up, because look, if I take that distance going straight up, I could actually chop off this triangle right here, move it right here, and look what I just did. I just made the rectangle. So that's why you can still do base times height. It's still 4 times 3, just like our last problem, okay, because we're sliding it over and counting it toward our area, okay? So base times height, it's going to be multiplying this bottom right here with the straight up and down height, and that will get you the same thing. So whether it's a perfectly straight parallelogram or it's one that's slanted over, base times height is going to get you the area. All right, then triangles. Again, we're building off what we know. Triangles, again, perimeter goes all around, but the area of a triangle, if I make any shape of a triangle, and I'll just make this one, if I were to double it and then stack it on top, look what I just made. I made a parallelogram. So a triangle, and you can try this no matter what the shape of the triangle is. If you double it, it's going to be half of a parallelogram. So the formula for the area of a triangle is going to be base times height chopped in half. Or sometimes you'll see it written as base times height, and there might be a 1/2 in front of it. Dividing by 2 and multiplying by 1/2 are the exact same thing. Okay, so again, but that base and that height, I have to make that perfect perpendicular relationship. My base of my triangle is right here. My height goes straight up to the tippy top of my triangle. So I have a base of 1, 2, 3, 4, 5, 6 units times 3 units. So 6 times 3 is 18 divided by 2 is going to be 9. This triangle, is 9 units squared. All right, trapezoids. Okay, this one relates a lot like the triangle, but just one little variation. Okay, so the trapezoid, no matter what shape it is, the definition of a trapezoid, it's got 4 sides, and one set of those sides is parallel. So I'm going to make my top and bottom parallel. There's one, there's the other. Okay, guess what? If I double it and flip it over and put it on, guess what I just made? I made another parallelogram. Sometimes they can be slanted over. So it's going to be base times height chopped in half, except we don't go to a point like we did with our triangles, right? So we have to end up adding these bases, because combined, that's where they make that whole distance across that parallelogram. So I'm going to say 2 plus 5. So what you have to do when you're working with trapezoids is sometimes it looks like this: base 1 plus base 2. Then we get to multiply that by height, and chop it in half. So just remember with trapezoids, the difference is add your bases, okay? And remember, base and height have that perfect relationship. So this would end up being 7, because those are my bases added, 2 plus 5, 7. My height is 3, and I'm chopping it in half. All right, then we get to circles. Now, I don't have any fancy way to remember circles. They always have their own rules. In fact, they don't even have the name perimeter for their name for perimeter is actually circumference. So circumference equals pi times the diameter. So you need to understand the diameter is that line that cuts exactly through a circle. It doesn't matter where you cut, just like cutting a pizza, as long as you cut exactly through the middle. And then the diameter is always twice the radius, or you could say 2 radii, if you want to get fancy, is going to be equal to the diameter. So just make sure that you understand that relationship. Radius is always half the diameter, or you could say diameter is always twice the radius. All right. So for circumference, we have either pi times diameter or pi times 2 radii. All right. Then area has its own little formula, pi times r squared. Not r times 2, r or radius squared. So if r is 3, it's not 6, it's 3 times 3, which would be 9. Or if r was 5, it wouldn't be 10, it'd be 5 times 5, which is 25. Okay, and we'll use 3.14 as pi. All right, so in Indiana, we take the I-STEP. That's our standardized test, and so we get a reference sheet when students take that test. And it has all these formulas on it, and that's great, but if you don't know how to apply them, it's not going to help you to have this sheet, right? So if you understand, oh yeah, rectangles, there is length times width. That's right, Mrs. Landers said it's like base times height. Same with the parallelogram. They make it look different, but it's the same thing. And then she was saying that, oh yeah, triangles are always half that amount. So she multiplied that by 1/2, or you could divide by 2. Same thing with that trapezoid, but remember we got to add those bases. A square is base times height, just like the rest of them, but in this case square sides are equal, so they just square the side. And then we have those funny circle formulas that we have to remember, okay? So that is just what we went through. You should be familiar with that now, okay? So let's apply that. Find the perimeter of this shape. Well, we're just going to imagine Perry the platypus walking around. If this is a rectangle, the other side is going to be 6 and this other side is going to be 10. So I have 6 plus 10 plus 6 plus 10. Or I could think of it as maybe 12 plus 20, right? However you want to get there, as long as you're adding up all those sides, 32 units is going to be your answer. Now we're talking about perimeter, one dimension, so we're not doing units squared. Perimeter is just plain old units. Perimeter of this shape is just going to be adding up those sides. So 8 plus 8 is 16 plus 10 is 26 units. All right, finding the circumference of a circle is pi times diameter, or you could think of it as pi times 2 radii. And either way, it's going to be 6. Another 6 would give me a diameter of 12. So pi times 12. I just plug in my calculator 3.14 times 12, and I get 37.68. Oops, 37.68. All right, now on this one, it's a little bit different. Okay, sometimes you're going to get these odd shapes, like this swimming pool here. Is not just a rectangle or a triangle or a circle. It's going to piece together shapes. So you have to sometimes look at these shapes and find the shapes that they're made up of. Okay, in this case, we have a regular rectangle and then a semicircle. So to find the perimeter, we're going to have to do half, because it's just half of the circle, half of the diameter. So what I'll do is I'll say, okay, I know that pi times diameter is going to be the whole perimeter. I only want half that, so I'm going to chop it in half, right? Then I'm going to add that to the perimeter of the rest of our rectangle. Well, we know that this is 8. We know that this is 4. This would be 8. And since this distance is 2 right here, and the whole other side is 4, this has to also be 2. Okay, so sometimes you have to look at the opposite side of a shape to kind of fill in the gaps on the other side. So there's not too much to do on this one that's out of the ordinary, but pi times diameter, or pi times 2, because our diameter is 2, divided by 2. Oh, look, I can go ahead and cancel those out, right? Plus 8 plus 4 plus 8. Oh, and I forgot my plus 2. That small little section right there, okay? All right, so now I need to go through and just add those up. Well, remember, pi is 3.14, okay? Plus 8 plus 4 plus 8 plus 2. Okay, now you could have done some of that mentally, but I got the answer of 25.14 units. All right, again, perimeter is just one dimension, Perry the platypus walking around the pool. All right, now let's try some with area. These are the exact same shapes. We're not finding the outer edge, we're finding the space that fills them. So now the area of a parallelogram, remember, base times height, in this case 10 times 6. If you tipped it over, it could be 6 times 10, you get the same answer. So it's now 60 and our units are squared. For finding any triangle, remember if I took a triangle and I doubled it and flipped it over, I just made a parallelogram. So I'm going to take base times height and chop it in half. My base and my height have to have that perfect relationship. 8 is not going to be used as we work through this problem. Base is 10, our height is 6, going straight from the bottom to the top. We chop it in half. Follow order of operations. 10 times 6 is 60 divided by 2. You get 30 square units. Again, square units because we're finding the area. All right, finding the area of a circle. Area of a circle equals pi times r squared. In this case, our r is 6. Sometimes they give you the diameter and you have to make sure that you're dividing it in half to make sure you're using the right radius. Okay, so I'm just going to take my calculator and plug in, and I know that 6 squared is 36, but I'll go ahead and do 3.14 times 6 times 6, and I get 113.04 units squared. All right, back to our crazy swimming pool, right? Sometimes I do this. I'll say, look, I need a semicircle plus a rectangle. And then I'll write my formulas right below. I'll say, okay, well, I know that the whole circle is pi r squared, but this is only half a circle, so I'm going to chop that in half. And I know that the formula for a rectangle or a parallelogram is just base times height. So if I draw that visual and put my formulas below, that really helps me. But remember, there's not a formula for a semicircle, really. You have to know the formula for a circle and know to just chop it in half. So our radius is not 2, our radius is 1. So pi times 1 squared over 2 plus 8 times 4. And I'm going to go ahead and put that in parentheses so it stays separate. Okay, so let's start with our left side. We've got pi times 1, which is just pi. So 3.14 is in our numerator. Divide by 2. I get 1.57 plus 8 times 4, if you plug that in your calculator, but you should really know that in your head, is 32. 32 plus 1.57 is 33.57 units squared. All right, hopefully that helped you understand perimeter and area a little bit better, and you're prepared now to go on to my session that teaches more about volume and then later on surface area. Thanks for coming. Bye.